The forest stand dynamics of threatened spotted owl Strix occidentalis subspecies habitat by Hoyt. Spotted owls are a fearsome nocturnal perch and pounce predator occupying a range from central Mexico to southern British Columbia. There are three subspecies of spotted owls, the Mexican, Californian, and northern. Two of these, the Mexican and northern, are listed as threatened under the Endangered Species Act. Spotted owls forced to live in small patches of forest become susceptible to starvation, predation, and further loss of habitat due to the effects of wind on stand edges. Spotted owls are forest specialists and are commonly associated with undisturbed, closed canopy or old-growth vegetation. However, resilient populations of threatened subspecies have adapted to more disturbance-prone forest types. This podcast examines the stand dynamics of Mexican spotted owl habitat in ponderosa pine oak forest and northern spotted owl in dry mixed conifer. Northern spotted owls are the smallest spotted owl and require an expansive area of dense stratified and generally complex forest. The population is distributed widely, but in patches throughout the southwestern United States and Mexico. The primary threats to spotted owl populations are loss of habitat and encroachment. Spotted owls occur most frequently in association with mixed conifer forests. Yet these birds occupy a ponderosa pine oak forest south of Flagstaff, Arizona, containing no mixed conifer. Southwest pine oak forests were historically more open areas due to a frequent fire interval. Human activities such as grazing and fire suppression have created overstock stand conditions throughout this forest type. These conditions existed historically as an exception. Only pockets were spared from major disturbances for extended periods of time. When overstocked areas did burn, they were likely stand replacing events. The first phase of stand dynamics, or the progression of a forest's structural development over time, commonly arises from stand replacing events, like fire, wind throw, insects, and disease. In the stand initiation phase, plants recolonize disturbed areas. In the pine oak forest type, ponderosa pine regeneration in bare mineral soil and gamble oak sprouts should account for a large percentage of post-disturbance colonization. During this phase, growing space is shared with grasses, forbs, shrubs, and possibly a few other tree species. As the initial cohort grows, it enters the second phase of stand dynamics, known as stem exclusion. Stem exclusion occurs when the most vigorous plants overtop or outcompete neighboring plants, resulting in their exclusion from the stand. Shade-intolerant ponderosa pine often dominates the stem exclusion phase. Gamble oak is more tolerant of shade and will likely emerge from the stem exclusion phase as an understory or co-dominant species. However, in the dry forests of the Southwest, competition for moisture also contributes to stem exclusion, giving established gamble oak an advantage. As the two species grow and senesce, disease, insects, mechanical disturbances, and perhaps fire will claim individual or small group of trees. Beginning the third phase of stand dynamics, understory reinitiation. In this phase, trees eliminated by minor disturbance open growing space for additional cohorts. Colonization of gaps depends on available resources and competition with remaining species. The fourth and final phase of forest stand development is old growth, which is reached once the entire initial cohort is replaced via understory reinitiation. Gamble oak may slowly assume a more prominent role in the canopy as the old growth phase progresses due to its ability to exist in the understory and the shade intolerance of ponderosa pine. Frequent fires will produce relatively open stands across the landscape. The practice of fire exclusion implemented in the past century has led to dense, stratified, and complex Mexican spotted owl habitat. If fire is excluded, then other disturbances will act on the stands, such as disease and wind throw. These create additional unique plant and forest structures crucial for Mexican spotted owl nest sites and roosts. While the intricate structures associated with old-growth forests constitute the bulk of an owl's range, they will use and travel through many vegetation types in various stages of development. The Mexican spotted owl living in pine oak forests have one of the largest home ranges of any spotted owl subspecies. Additionally, spotted owls require habitat connectivity to facilitate mating and dispersal. Fire exclusion has created an unnatural overabundance of niche for this subspecies. Problems can arise if large tracts of habitat are lost in high-severity wildfires. Fire was previously a threat to individual owl home ranges. However, it is now threatening much of the pine oak forest type. The remnant shelterwood cuts of the forest industry partially halted by this bird have contributed to the sporadic formation of desirable habitat. Large seed trees in advanced regeneration left following harvest can stratify into a two-level canopy. Additional cohorts, originating following disturbances, can create an uneven age stand, thereby approximating old-growth forest in structural complexity. Thinning is currently being implemented in these forests to reduce fuels. While spotted owls are easily displaced by human activity, treatments may be necessary for the continued existence of the subspecies. I recently visited a nest stand on the Coconino National Forest, just north of Howard Mountain, containing a number of previously used nests and one that was currently occupied. This ponderosa pine gamble oak association contained evidence of logging, an abandoned shelter woodcut, high stand densities associated with fire suppression, and several gigantic oaks. This stand is on a slight north-facing slope, although aspect, as well as elevation, play less of a role in determining an owl's home range than does forest structure. The northern spotted owl also requires an expansive area of dense stratified and complex forest. On the east side of the Cascade Mountains, owls are found occupying a range consisting predominantly of dry mixed conifer forests. In northeast California, a stubborn population of northern spotted owls exists on the fringes of the range. Insects, disease, and fire limited the amount of old-growth forest structure in the dry mixed conifer regions east of the Cascades prior to European settlement. However, anthropogenic influences have now altered these disturbance cycles. Forests supporting northern spotted owls are comprised of a variety of species, depending on microsite suitability. Soil type, dispersal, elevation, aspect, available resources, and exposure all interact to determine which tree species will be present at a given site. Eastern Cascade spotted owl nest stands are highly variable in stand development stage. A disproportionate amount of nest stands are located outside of old-growth forest. They occur often in relatively young stands where high densities and logging remnants simulate desirable habitat. This is interesting given that the vast majority of northern spotted owls west of the Cascades are located in undisturbed old-growth forest. While stand composition of nest site varies, owls still have many structural requirements. An open understory to facilitate hunting, perch and pounce, is paramount. This typically correlates with a relatively closed canopy. However, on drier sites, moisture availability may contribute to an open understory. Stand stratification and mistletoe infection may be required for owls to nest and roost. The prominent tree species in the area of northeast California supporting these birds are ponderosa pine, sugar pine, incense cedar, Douglas, white, and black fir. The stand dynamic phases of these forest development roughly follow the stand dynamics outlined for Mexican spotted owl habitat in pine oak forests. However, there are now a number of species with varying shade tolerances that interact to shape forest structure. The more shade-tolerant species will eventually replace the early cereal species without large-scale disturbance. Fire exclusion has resulted in dense fire-prone areas, and large sections of the forest may now be at risk of burning, similar to the situation in northern Arizona. A shifting composition towards more shade-tolerant species is occurring in these forests. Douglas fir, a shade mid-tolerant species, is the preferred nest stand tree of northern spotted owls east of the Cascade Crest. As Douglas fir is being replaced by more shade-tolerant species, owls will need to continue to adapt. Bold restoration steps have been taken, yet new threats to the owl continue to emerge. Competition from barred owls has contributed to the decline of the spotted owl. Barred owls are larger, more aggressive, and have a broader diet. This generalist species is more resilient to declines in habitat quality. Climate change is also expected to alter spotted owl distribution. Impacts of this phenomenon will have unknown consequences, although it is speculated that warming temperatures will result in drier conditions and a decrease in closed canopy forests, areas sought out by owls. Attentive forest management is required if the spotted owl's complex habitat is to recover. This species faces significant challenges in the future. Perhaps examples of resilient subspecies adapting to disturbance-prone environments should inspire hope for the spotted owl's continued survival.